All right, well, today we're going to be talking about this weird number called e, but also we're going to review a little bit of the law of exponents. And some of you guys might have forgotten some of these rules, so we're going to recap on some of them. But if you need extra practice, make sure you go check out some other type of videos. You know, you could literally type into YouTube laws of exponents and find plenty of examples. Um, here are a few of the exponential rules here. So saying like if you have like, I don't know, like two numbers there, they have the same base but different exponents, you can take the exponents and add them up. For example, if I had like x cubed times x to the, seventh or something like that, that'd be x to the 10th. So you can multiply things that have common bases and just wind up adding their exponents. Same exact thing here with division, though. Instead of division instead of doing like a multiplication here and adding, we're going to do division and subtracting. So if I have like x to the 7th over x cubed right there, once you subtract your powers, you'll get x to the 4th. Another good example of that would be something like this here. Sometimes you'll see these examples where maybe the bottom has a higher power, so like maybe x squared here and then x to the 10th on the bottom, and then we would subtract the powers and say that that is x to the, I don't know, I guess you could say it's kind of like x to the negative 8th or x to the 8th on the bottom right there. And those are kind of two examples of powers stuff there with division there. So really just need to know subtract the powers. Okay, we said this in the lesson yesterday here. Anything raised to 0 is going to be 1. That one's pretty straightforward. Anytime you have a power raised to a power or a power outside of parentheses like that right there, we're going to go and multiply them. So like for example, if I have like 4a to the 4th, I guess cubed here, then you would say, oh, that's kind of like saying the same thing as a to the 12th. Okay. Couple more here. This one's kind of similar to the last one there. If you have a power outside like this here, you distribute the power to both of these. It's like if I had x squared y to the 6th times like all that raised to the 3rd power, you'd say that's x to the 6th power, and then I guess y to the 18th. So that would be like a little example there of that. Fractions, if you have a power outside of a fraction there, it's really just like you're distributing your power to both of them. So if I have like, I don't know, let's use numbers here. If I have like 1/4, I guess squared right there, that's the same thing as saying 1 squared over 4 squared, which gets you 1 over 16. That one's dealing a little bit more with just regular numbers and stuff. All right, negative powers, we saw this in the video yesterday. If you have something with negative powers right here, you can change it into a fraction and then make it to where the fraction, the power right there is going to be a positive power. And I'll show you kind of two variations of this here. So like if you have x raised to negative 2, this will be 1 over x squared. Now, sometimes we might see this here, like another variation to it. If we have 1 over x to the, I don't know, negative 5th, we flip that fraction and make it x over 1 right there, but then to the positive 5th right there. So basically what I say with negative powers is it flips the fraction that you have. So that's just recapping a little bit of your laws of exponents. We're going to practice them here in just a second with this number called e. So many applications of exponential growth and decay use a natural number e. Find e in your calculator. There's a button in your calculator. You usually, I think it's over on the right hand side kind of by the division, and you hit second and then that number right there, and then that'll punch out the e button. So if you're having trouble finding it, you could Google it real quick or just ask your teacher, but you usually hit second, and then I think it's division off the top of my head. I can't remember though. But anyways, when you type that in and then you hit enter, e is some crazy decimal number that goes on forever. I think right now they have it out to about 1 trillion digits is what I think I read online just a minute ago there. But anyways, we don't really care about how many digits or how far on the digits we're going to go. Really, you'll need to know that it's about 2.7 or maybe 2.71. But that's, a couple of digits right there of e. And what it is, we use it with continuous growth quite a bit. And I don't know if you guys remember the compound interest formula that we did from yesterday here, but it kind of had this fraction kind of looking like this right here with the compound interest. And what happens is if you take this n right here and increase it to like a really, really big number, and then this n as well, it'll eventually come out to where this thing rounds to about this e number right there. It's kind of getting a little bit into calculus and stuff. What do you need to know? You need to know that e is about 2.7 or 2.71 right there. And yeah, that's about it there. We'll use it in models a lot. I think here in a minute we're going to have like an equation with this model right here. And that's like an actual real equation that uses the e number here. But anyways, we're just going to practice a couple things here. Some of our laws of exponents with e. So if you have e to the 9th and then e to the 6th, we'll add our powers. That'll be e to the 15th. So nothing crazy there. That's just kind of using that rule that we did above. If you have a division problem like this here, we need to divide these coefficients, but then since we have multiple e's right here with different powers, we can actually subtract the powers. So that's going to come out to e, I guess, to the 5th once we subtract our powers. And then actually the 60 over 12, you just go and divide those. 60 divided by 12 should get you 5. So that'll be 5e to the 5th right there. So divide your coefficients there and subtract your powers. Okay, if we have something like this where we got 3 outside of all of this right here, we need to go and take this 3 and distribute it to each piece right here. So you have e raised to negative 5x, and then you have the negative 10 right there. So e raised to the negative 5x, if we multiply those powers, that'll be negative 15x. And then if we do 10 raised to negative 3, or I'm sorry, not negative 3, to positive 3 right there, that's like saying negative 10 times negative 10 times negative 10. So I think that gets us negative 1,000. And then this would be, I guess, kind of what this all looks like right here. Now, another way you could simplify it, since you have this negative power, is if you wanted to write it as a fraction, you could write it as negative 1,000 and then divided by e to the positive 15th over x right there. And that'd probably be the most simplified version right there that you can do. Okay. All right, one more here. This one, okay, I guess we have e raised to x. I guess one way you could write this here, I guess, it's like 7 divided by 1 right there. That'll be 7. And then I guess the way you could write this here, you could take these e's here, and since it's division, you'd subtract the powers. That'd be 10, I guess, minus x, kind of like that right there. I guess if x was a number, we could actually simplify that a little bit more, but that's all we can do right there. So that is that on that problem right there. Okay. All right. Use a calculator to figure out or evaluate the expressions. So that would just be all in your calculator. You'd find that E button. You'd hit raise it to 6. And then let me get my notes here because I don't have a calculator in front of me. So this will come out to about 403. And then let's go out 3 decimal places here. That'd be 403.429. And that would be that right there. E raised to negative 0.28 right here. Once again, just use your graphing calculator for that. Find the E button. I think it's second divide, if I remember correctly. It's over there near divide. Anyways, if you raise that to negative 0.28, that'll get you 0.756. And these are all approximations. I don't know if I emphasize that well enough here. Usually we use squiggly lines kind of like this for approximations. So it's really close to that decimal. Really, I need to change those both to approximations. So anyways, that's that. Let's go and graph E and see what the graph looks like. And honestly, since everything's decimals, there's not a ton of nice numbers to graph here. Really, I'll probably graph just 2 numbers here. Now, the nice thing about e's, or anything raised to 0, I guess we can always say is 1. So we know that for sure. And then I guess if I plugged in 1, we'll get that 2.7. And then I guess we'll go ahead and graph that 0, 1, 1, 2.7. Just try to get it as close as you can. And then you got an asymptote here at the bottom. And then draw your exponential growth function going up like that. Domain and range, we'll just say from negative infinity to infinity. And then range, it'll start at 0, not including 0, and then it'll go up forever. So from 0 to infinity. The y-intercept, say that's 0, 1. And then the asymptote is the line y equals 0. Anyways, that is that. Let's see here. Describe the transformations from this first graph to the parent function graph of e right there. So this is kind of just using some of the stuff from yesterday, some of the stuff we've been doing. We know a -2. Hopefully we know by now that moves us right to. It's kind of like in your parentheses. We call it, I guess, in your exponent right there. A +3 is going to do a vertical translation up 3. And then this negative will be a reflection across the x-axis. So reflection across the x-axis. I'm going to say right 2 units, or if you need to say translation right 2 units. And then up 3 units as well. And that is that there. Alright, next one here. I guess the length in centimeters of a tiger shark can be modeled by this equation right here. I'm not going to read that to you, but where t is a shark's age in years, estimate the length of a tiger shark that is 3 years old. So we'll go and take 3. All we got to do is plug that in right there. So figuring out this length. And don't even try to simplify any of this here. What I would do is literally type this into your calculator the exact way it looks here. The only thing that's changing here is we're going to plug in a 3 right in there. Okay. And then let me pull up my notes here. When we do that, it comes out to about 180. And that's, once again, that's all in your graphing calculator. 180 centimeters. Sorry, they're mowing outside of my house right now, so it's kind of loud. Alright, next thing here, compounding continuously here. So yesterday we talked about compound interest, but when our money is compounded very frequently, we refer to it as continuously compounded. When you see the word continuously compounded, that's when we're going to use a different formula. The following formula applies. So here it is right there. Now a lot of the stuff is going to be the same. We're still going to say A is the final amount. We're going to still say that P is the principal or the starting amount. R is going to be the rate as a percentage or decimal. And then T will be the time, the amount of time we look at. So, and then E, what is E? Well, E is that decimal there, which we're going to use our calculator. And I guess you could use 2.7, but I would just use the calculator button for that. So let's do one here. So you deposit $3,000 into an account that pays 3.5% annual interest compounded continuously. So that means P will be 3,000. The rate was 3.5, so move that decimal over twice. That'll be 0.035. And then I guess time will be, in this case, 3 years. And then we just plug all that stuff in to our formula. 3,000 E and then raised to rate, which is 0.035, and then times your time, which is 3. And then that'll equal your final amount. And then once again, that's all in the graphing calculator. Type that in the exact way it looks. All right, and when you punch that out, you get $3,332, and it looks like about 13 cents. And then that is your answer.